Hello everyone, and welcome to part 2 of my practice test for Survey of Calculus. Survey of Calculus is basically Calc 1 without trig, and this is the practice test for the integrals chapter. Right now we're focusing on number 11. That's where we got up to. Let's go down a little bit. We've got 11. Alright. Number 11 reads the integral of 6x over 3x squared minus 5 to the fourth dx. I'm looking at this. I'm looking for something obvious to do. Maybe I could FOIL all this out, which would be 3x squared minus 5 times itself 4 times, and then I could attempt to look at the numerator and maybe factor something out. I could try all of that, but what I'm going to do instead is I'm going to try a technique known as U substitution. What you do in U sub is you look for something and you just randomly decide that it's going to become U, and as you go through more examples you get a little bit better at identifying what U should be. But for the first couple, you're just along for the ride, really. What you're doing is you're going to take the derivative of U, so that you can, of course, find the integral. So we've got U. Let me just walk you through this one step by step. U is, I'm going to make that equal 3x squared minus 5. That's an awful 5. Minus 5. Not 3x minus 5 to the fourth. That's because we have to find du. And if I were to find the derivative of it to the fourth, I'd have a nasty looking chain rule. And really the only explanation that I would have as a novice is I don't want to do the chain rule. Because I've seen this a couple of times, the explanation is because I know what I'm looking for. And again, you will as well. So what I did is I take the derivative of this side, of the U side, and I'm going to take the derivative of the X side. So I've got the derivative is 6x, my constant turns to 0. And of course dx. Because as we learned with our implicit differentiation, whenever you take the derivative, you always have to put a dx at the end, by chain. So let's just go ahead and look for a du. I see I've got a 6x, well that's good news, and it looks like I've got a dx, so I think I've identified my du. Do I have a u? Oh, thank goodness, I have a u. I've got my u right there. So let's just go ahead and substitute. So I've got the integral of, this is du over u, but it's u to the fourth power. Alright, the hard part is done. Now it's just basic power rule, the general power rule. So I'm going to bring this into the numerator. So I wind up with the integral of u to the negative fourth du, and that's going to equal, I'm going to add 1, so that's negative 3, so I divide by negative 3, so I multiply by negative 1/3, u to the negative 3 plus c, and I finish it off by saying negative 1 over 3 u to the third plus c. Actually, we're not done yet. We started our problem in terms of x. So we shouldn't be ending in terms of u. Thankfully, I know what u equals. In fact, I wrote it at the very beginning of the problem. So let's solve back in for u. One more final step. We've got negative 1 over 3. What is my u again? 3x squared minus 5. 3 times 3x squared minus 5. That's going to be 2 to the third plus c. And that's where we can call it quits. The algebra is done nicely. We don't have any radicals. Nothing's out of place. Good. All right. Let's go on to number 12. Number 12 reads the integral of 18x over 9x squared plus 35. And then we've got a dx sitting on the outside. For those of you who don't know, if we've got something sitting on the side here, it's being applied to the numerator, not the denominator, not both the numerator and the denominator. It's simply applied to the numerator. Okay, so that dx is sitting in the numerator. It's just a style, really, a style choice to put it there on the side. Okay, so we could try and maybe factor the denominator in some sort of weird addition of squares, or combination of squares, whatever that would be called. But what I'm going to do is I'm going to use my U substitution technique, because that's how I'm comfortable, and I'm afraid of change. Just like everyone. U equals, well, because I know, now that I've gone through one problem, I know that I'm going to wind up taking the derivative. So let's look through, let's parse through. If I take the derivative of 18x, I'll get 18. Do I have an 18 down here? No. In fact, that 35 is kind of odd. Well, let's see. If I take the derivative of 9x squared, well, I wind up with 18. And the derivative of 35, well, that's going to go away. So that oddity doesn't matter. So this looks like my best choice for u. So 9x squared plus 35. And then, of course, we're going to take the derivative of both sides. So here's my u. Derivative is du. Derivative of this, well, let's find it out. We've got 18x, okay, and that goes to 0. Awesome. Oh, but we can't forget the dx. Okay, so it looks like I can identify my du. Do I have a u? I have a u. Sweet. So let's substitute. That's why it's called u substitution. We've got the integral of, well, this is going to be du over u. Alright, this is a special case. It's not the power rule. It's actually something called the, I don't know what it's called. I wish I did. The log rule. I have the formula. It's the integral of du over u is equal to the natural log of u plus c. Well, we've got just that. So that's going to equal the natural log of the absolute value of u plus c. That's the natural log of the absolute value plus c. The absolute value of u plus c. My u is 9x squared plus 35. So I've got the natural log of 9x squared plus 35 plus c. And we're done. Awesome. That wasn't so bad. And it gets easier as you are more exposed to it. Let's try 13. We've got the integral of 3x squared over the square root of 1 minus x to the third. Or dx, of course. It seems like it's a trend where we are picking the denominator to be our u. Well, let's see if it's still the case. I'm going to choose, kind of like how in number 11 we did not include the power. We didn't include the power for our u. I'm not going to include the square root, because that's a power. The square root of 1 minus x to the third is equal to 1 minus x to the third to the 1/2 power. Just in case you didn't know. So it's a power. So I'm not going to include that. So my u is equal to 1 minus x to the third. I'm going to take the derivative of both sides. I wind up with the derivative u equals, well, that's going to go away. 1 is a constant. We've got negative, that negative stays, 3x squared. Okay, cool. I've got, I can see my u. Here's my u. In fact, I know that's my u because I picked it. It's not just random. I have got a du, almost, oh here's my dx, almost a du. I'm missing a negative sign. So what I'm going to do is I'm going to go ahead and throw a negative sign there, and in order to balance my equation, my expression, rather, in order to balance my expression, I'm going to put a negative sign there. Because a negative times a negative is a positive, so nothing happens, nothing changes. It's equal, and I can still do my integration like I should. And a lot of math is just playing with the numbers. So let's go ahead and replace du and u. So we've got the integral of, well, negative sign, can't forget that. We've got du, of course, on top, over u to the 1/2 power, as we set up there. Okay, now let's bring up my 1/2 power. So I've got negative integral of u to the negative 1/2 du. And now that's a power rule, which equals, we add 1, so that is going to be 1/2 divided by 1/2. That's the same as multiplying by 2. So we've got that negative sign there. 2, and then we've got, it's going to be u to the 1/2 power plus c. Now let's just plug in our u again, re-substitute. We can't end our problem in u because we started in x. So finally we get negative 2 times 1 minus x to the third. We've got 1 minus x to the third, and this is in a square root. I didn't forget about that. Plus c. And that's where we can end it. Not too bad so far. It's easy to see where you could get lost, but practice, practice, practice. Practice makes perfect. Number 14. We've got the integral of x squared plus 3 over the third root of x to the third plus 9x. We're going to say dx. Well, let's just approach it based on the trend, not even using any logic. I'm going to take from the denominator, and I'm going to not include the power that's on the outside, and I'm going to make that my u. So let's do that. Just following the trend of the last, 4 problems. U is equal to x to the third plus 9x. Now let's take the derivative of both sides to solve for du. That equals 3x plus 9. Oh, that's going to be 3x squared, excuse me. And then this is going to be, in parentheses, dx. Okay. I've got my u. There's my u. Actually, let's change colors. I like to change the color. There's my u. I need to find my du. I've got x squared there, and I've got an x squared there. But what I'm missing is a 3. And here somehow that's a 9. This is a 3. Wow. That's kind of overwhelming. Until you realize that you can put a parenthesis, multiply it by 3, so, and then you'd have the same number. If I were to say 3 times x squared, I'd have 3x squared. And if I were to distribute into the plus 3, I'd have plus 9. So that multiple of 3 fixed everything. Only it didn't, because we have to balance the equation, which isn't hard at all. We just say 1 over 3. If we multiply by 3, we have to divide by 3. Okay, the expression is balanced. And now it fixed everything. We're all done. Let's go ahead and substitute our u and du. I've got the 1/3, can't forget that, of the integral of du over u to the 1/3. Let's pull up our u to the 1/3. So I wind up with 1 over 3 integral of u to the 1 negative 1/3 du. And then we are going to do the basic, or the common power rule, whatever the power rule. Plus 1. So negative 1/3 plus 1 is 2/3. Dividing by 2/3 is the same as multiplying by 3/2. So we've got 1/3, 3/2, u to the power of 2/3 plus c. Well, this 3 and this 3 cancel, and we wind up with 1/1/2 u to the 2/3 plus c. All we have to do now is back substitute for u. X to the 3rd plus 9x. So we've got 1/2 x to the 3rd plus 9x plus c. And we're done. Beautiful. What number was that? That was 14. Let's go on to 15. Okay, in our career of integration, we know a lot about the natural number and the natural log. How come we haven't seen any so far? Well, next question. The integral, that's number 15. I guess I should label them, huh? The integral of e to the x dx. Well, this is one of our formulas, actually. The integral of e to the x dx is equal to e to the x plus c. I recommend that you know that formula. Actually, the official formula is e to the u, the integral of e to the u, du equals e to the u plus c. And when solving these, the trick is to find u. I'm giving it away. But I hope you see how this relates to that formula. Natural numbers is a very easy thing to integrate. Let's try an applied one, number 16. We've got the integral of negative e to the 0.00, no, not 2 zeros, 1 0, 625x dx. Well, we've got to find our u. In the equation, it looks like the u is the exponent. So I'm going to go ahead and call that our u, our exponent. So if I say u equals 0.0625x, then take the derivative of both sides. Du must equal 0.0625, and that's it. I've got a u, but of course we do. I picked it out of the equation. But I'm missing a du. This is supposed to be dx. I'm missing a du. I can add that in. I can multiply by 0.0625, and then I'll have a dx right there, so long as I divide by 0.0625. And all of a sudden, math works again. So we've got 1 over 0.0625 times the integral of negative e to the u du. And now we can just follow the formula as we would. Otherwise, actually, if you're a little bit confused by the negative sign, just go ahead and factor out the negative sign by the common multiple rule. So we'll wind up with negative 1 over 0.0625 integral of e to the u du. Now it fits the formula perfectly. And the formula is the integral of e to the u du is e to the u. So I've got negative 1 over 0.0625 times e to the u plus c. So I'm going to just multiply that by my numerator, so I wind up with negative e to the u over 0.0625 plus c. And our last step is to back substitute for u. Here's our u. Let's back substitute. So we've got negative e to the 0.0625 over 0.0625 plus c. And we're done. let's look here. Ooh, another fun one, number 17. 17, we've got the integral of 6x e to the 0.5x squared. Well, in the formula, my u is my exponent, so let's go ahead and look at the exponent and set that equal to u. So I've got u equals 0.5x squared. Take the derivative of both sides of this equation, and that equals 2 times 0.5 is 1, so I'm just going to put x dx. I have got, no, I didn't write my dx. What am I doing? X. Okay. So I've got an x dx, but now I've got this extra 6. Do I want that extra 6? No. Thankfully, we can just pull it out by the constant multiple rule. Constant multiple rule. So I've got 6 integral. Let's go ahead and use u du form now. So I've got e to the u du, and that is going to be 6 times e to the u plus c. And now we can finish it up by saying 6 e to the 0.5x squared plus c. Yeah, that's it. Alright, let's move on to number 18. We've got the integral of 1 over x plus 6 dx. Here, I'm going to use u substitution. Just by the pattern that's been presented, the past 8 problems have been very predictable with the u substitution. It's either the exponent with the e or it's the denominator. So in this case there's no e, so it's the denominator. U equals x plus 6 du equals, well, what's the derivative of x? Well, that's just dx. What's the derivative of 6? Well, that's 0. That's gone. Okay. So actually let's put 1 there. So I've got 1 dx. I think I found my du. And here's my u. So once again, I find myself with the integral of du over u, which is our natural log formula. So I've got the natural log of the absolute value of u plus c, or the natural log of x plus 6 plus c. And we're done. That was a really simple one. How long is this video going? A little bit longer than the other. Let's cut it short at number 20. We're almost there. 19. We've got the integral of x to the third over 16 minus x to the fourth dx. Let's go ahead and set the denominator equal to u. U equals 16 minus x to the fourth. Du equals, well, the derivative of 16 is gone. That's nothing. The derivative of negative x to the fourth is negative 4x to the third dx. And just so you know, it won't always be the denominator. For knowledge's sake, it will not be. But for this, probably honestly for this class's sake, it will be. But if you try the denominator and for some reason it's just not working, try something else, because it won't always be the denominator as you progress through your calculus classes. So I've got my u, they match up. Let's use a different color. Now let's find our du. I've got an x to the third, an x to the third. I know this is going to work because I'm not missing an x, I'm missing a constant. And I can add in a constant by the constant multiple rule. So, okay, my dx is there, my dx is there. So I'm going to throw in a negative 4, so long as I divide by negative 4. So I divide by negative 4. And now I can substitute for u du. I've got negative 1 over 4 integral of du over u, or negative 1 over 4 natural log of the absolute value of u plus c, or the negative 1 over 4. Actually, let's go ahead and do that first. What we can do by property of logs is bring any coefficient into the exponent. So I'm going to go ahead and do that. So I've got the natural log of the absolute value of u to the negative 1 over 4 power plus c, and I'm going to simplify that further. The natural log of 1 over the 4th root of u plus c. And now let's back sub u. U is 16 minus x to the 4th. The natural log of 1 over the 4th root of 16 minus x to the 4th plus c. Okay. I'm sure we could reduce that in some way, but you know what, that looks good for me. Let's do one more. We've got number 20. That's going to be the integral of 1 over x natural log of x dx. Now, as a Calc 2 student, I remember getting tripped up on this. I just could not remember what on earth I was supposed to do. And really, the whole trick here is to try both of them as u, because there's two things in the denominator, if you don't see that already. We've got an x in the denominator, and we've got another natural log of x. Well, let's try x. Okay, so we've got x is my u equals x. So du must equal dx. Okay, so I've identified a u, a du, but what do I do with this natural log of x? What do I do with that? Well, that's an interesting problem. Well, let's try the other way, since that clearly didn't work as smoothly as the past 10 questions did. Let's try u equaling, let's erase that, u equaling the natural log of x. Well, the derivative of the natural log of x is 1 over x dx. Okay, so I've got u, here's my u, and I've got du, 1 over x dx. I think that works. So let's go ahead and u sub. I've got the integral of du over u. And that's a natural log. So I've got the natural log of u plus c. And my u is the natural log of x. So that's interesting. But the natural log of the natural log of the absolute value of x. That's unnecessary. Here we go. That's better. Natural log of the absolute value of x plus c. I almost want to guess and say that you could say natural log squared, but I'm not sure of that at all. So I'm going to feel much more comfortable leaving it as the natural log of the natural log of the absolute value of x plus c. Okay. I hope that you've learned something today. As you know, my name is Terry the Tutor, and I'll calc you later.